Good morning, class. Today we're going to once again look at our sine and cosine waves. However, we are going to be starting with the graphs themselves and using those graphs to determine the equation of the waveform. Now, I'd like to remind you, of course, that these are periodic waveforms. So we will largely be looking at just over a cycle of the graph. Each graph can be described by a sine wave equation or a cosine wave equation. And that's because, as you know, sine and cosine waves are just 1/4 of a period out of phase with each other. So we're going to read the question because in the wording, I have indicated whether I'd like you to treat the graph as a cosine wave or as a sine wave. Okay, a couple things to note. One thing is that this is the best image that I could get using my printer. However, I have posted a copy of this digitally for you in Blackboard so that you can zoom in and see more clearly all of the numbers on the graph. The next thing to note is that on the horizontal axis here, we have x, and on the vertical axis, y. And so that's why we are using x as the independent variable here and y as the dependent variable here. Okay, so why don't we get started with this first graph? Now, we're going to consider this to be a cosine wave. So what I want to do is indicate where the 5 critical points are for this cosine wave. Okay, so if I take a look at the cosine wave, remember it's going to have zeros at the 2nd and the 4th critical points. So that is actually here, and that's 2 pi, and here at 5 pi. Okay, so those are the 2nd and 4th critical points. So where would we consider the first critical point to be? So that would be where the graph is at its minimum of -1. So that's here when the x value is 0.5 pi or half a pi. Okay, the third critical point is where the graph is at its maximum of 1. So that's right here. That says 3.5 pi. And finally, the 5th critical point is when the graph is back at its minimum of -1. And that's happening right here. This says 6.5 pi. Okay, so these are the 5 critical points. And now I'm going to start the process of coming up with the equation of this graph. Note that to come up with the equation, all we have to do is correctly identify a value for A and B and C. Okay, help me out with this value for A. Remember, the value for A can be determined by noting the amplitude of the graph. So this graph has an amplitude of 1. So the distance is 1, the distance is 1, the distance is 1, right? So the amplitude is 1. Will we use +1 here or -1 here? Well, if this is considered to be the first critical point, then the graph at that first critical point is at -1. So the value of A then is -1 in this first example. So let me just see if we can have the graph visible plus my notes visible. Yes, okay, so let's do that. So in problem 1, we know that A is equal to -1. Next, we should try to determine the value of B. Now, in order to determine the value of B, we have to remember the formula the formula for period, when we see pi, so we know that the unit is radians, the formula for period is 2 pi divided by b. And so if we're trying to determine b, we need to know what the period is. Well, we should be able to determine the period from the graph because period means length of one complete cycle of the graph. So what that means is the length from this point to this point. So it is 6.5 pi minus 0.5 pi. And therefore, the period is 6 pi. Okay, so this again, this is the ending point minus the beginning point. So we're suggesting one cycle ends at 6.5 pi and begins at half a pi. So now we know the period length is 6 pi. So this formula becomes 6 pi is 2 pi divided by b. And if we just rearrange this equation, we find that b, therefore, is 2 pi divided by 6 pi. The pi's will cancel. b is 2 over 6, and this fraction can be reduced. It is 1 over 3. Okay, so now we know an a value and we know a b value. So the last thing we need to do is figure out c. Well, how will we do that? Well, we used our formula for period. Now we need to use our formula for phase shift. Remember, our phase shift formula was phase shift equals the negative c over b. And this formula works whether the graph was in degrees or in radians. So we know that b is 1/3, so we'll be substituting that here. If we're trying to determine c, we need to substitute the correct phase shift. And this is something we should be able to determine in the graph. What is the phase shift of the graph? Well, the phase shift is always going to be given by that first value. So in this case, the phase shift is equal to 0.5 pi, or 1/2 of pi. Okay, so again, it's always going to be given by the very first of the 5 critical points. And so into this formula, 0.5 pi is substituted here. Remember, b was 1/3. Okay, so now all we have to do is work out c. So c is going to be found by multiplying here and also by multiplying by -1. So the value of c is going to be -1/3 times 1/2 pi. Okay, and now this is the same as -1/6 pi, or we can say negative pi over 6. So you can either write -1/6 pi or negative pi over 6. Okay, I should show you maybe really quickly with the fraction button. Let me just grab that calculator. Okay, those of you who would like to use the calculator here, you know, oh, I don't want to get that glare going. So remember that you don't put the pi in here though when you're trying to use that fraction button, okay? So I'm just going to show you, I'll just put it there for a moment. We're going to do negative 1 over 3, okay? And I'm just gonna do times 0.5 times 0.5. Don't put the pi in. There it is as a decimal, but I don't like that. How am I gonna write that in my equation? So instead, I can hit the fraction button and I get negative 1 over 6. So negative 1 over 6 pi, okay? And this is the same as writing negative pi over 6. And in fact, we are now done because we know A is negative 1, B is 1/3, and C is negative pi over 6. So we take the equation, which is A cosine of bx plus c, and we write negative 1, which is the same as just having a negative sign, times the cosine, times the cosine of, now it's b times x, so 1/3 times x, or you could write x over 3, whatever you like. Okay, so that's the same as writing x over 3. And then it's plus c, so plus negative pi over 6, so minus pi over 6. And then we're all set. We have the desired equation for number 1. Okay, so we had to correctly come up with A and B and C so that we could then substitute into our equation. Okay, I'm going to definitely do another example with you. So let's take a look at the second graph right here. Okay, this time I've asked that we consider this to be a sine wave. Just a quick note, if you were asked to consider this a sine wave, you know, you would have to maybe consider this right here to be the first critical point. So first, second, third, fourth. The fifth would be not showing. You see? So if you use this as the first critical point, you could write this equation as a sine wave instead, but only 4 of the critical points would be visible. All right, in any case, we're going to treat this one as a sine wave. So remember, a sine wave has its zeros at the first, third, and fifth critical points. So here's a 0, here's a 0, and here's a 0. So those will be my first, third, and fifth critical points. This, by the way, says negative 0.2 pi. Okay, this one says 0.2 pi. And what do we have way down here? At the end is 0.6 pi. Okay, so I know those are difficult to read, but again, maybe in the video you can zoom in, I don't know. You can figure that out more than I can. And also, I have these posted as documents in Blackboard, and so definitely I know that you can zoom in on those Word documents. Okay, so this means that we're missing the second and the fourth critical points, so I think I'll circle them while I'm at it. The second critical point would be here at 0, and that's when the graph is at its maximum of 3. And the fourth critical point would be right here. This says 0.4 pi, and that's when its graph is at its minimum value of -3. So I've now got my 5 critical points, so this should help me figure out the graph's equation. So let's give this a shot. So I'm going to slide that up here so I can fit my page here. Okay, so like the last one, our objective is to determine values for A, B, and C. What's the amplitude of the graph? this distance is 3, this distance is 3. Remember, amplitude is always a positive quantity. But for A, should we use positive 3 or negative 3? The graph is going up to its maximum first before it's going down to its minimum. So this means as you move from left to right on the page, the graph is going up first to its maximum. And this tells us to use A equals positive 3. So we've got that taken care of. Now remember what we did next. The next thing we did was we worked out the length of one cycle of the graph. In other words, we calculated its period. That was found by taking the end point. Remember, this is 0.6 pi. And from it, you subtract the beginning point. The beginning point of the graph, however, is 0.2 pi. Negative 0.2 pi. So this means the period length is actually 0.6 pi plus 0.2 pi. That should make sense to you because this length is already 0.6 pi. And we have to still add this length to get a total length of 0.8 pi. You can do it just like we did the last one. End point minus beginning point. However, this time the beginning point is negative. Okay, once we have that period length determined, remember we can go to the period formula, which is 2 pi over b. Okay, remember the period formula is 360 degrees over b if the graph is in degrees instead. However, all of our graphs for this topic will be in radians. Okay, so we're always going to use this form. So in order to figure out the value of b, I simply substitute 0.8 pi here. I rearrange this to find b. So first b, you can picture multiplying on the left side by 0.8 pi, and then to isolate b, we would divide by 0.8 pi. So b is 2 divided by 0.8, and that's because the pi's cancel here, and 2 divided by 0.8 is 2.5. Okay, so that's our b value now determined. All right, the next thing we're going to do, of course, is try to figure out C. And C is determined by using the phase shift formula, which is the negative of C over B. So we know that right here will be 2.5. We need to substitute the correct phase shift here in order to determine C. What is the phase shift of the graph? The phase shift of the graph is given by the first point, the first critical point. So it's negative 0.2 pi. So that is what we must substitute on this left side. So we'll have this, negative 0.2 pi is the negative of C over 2.5. So C is determined. So if we want to leave the C here, remember we're going to move the negative with the 2.5, just like we did in the last one. In order to get the C by itself, we moved negative 1/3. And when I say we moved it, we multiplied the number on the left by negative 1/3. And we're going to do the same thing here. C is equal to negative 2.5 multiplied by negative 0.2 pi. Okay, so let's figure out what that is. we know that this is going to be positive, but you can just do negative 2.5 times negative 0.2 if you like. Don't put the pi in the calculator, there's no need. You're going to get 0.5 pi. So the pi must still be written on the page. You just don't have to put it in the calculator. In fact, you shouldn't, because you'll get a mess, right? If you did this, negative 2.5 times negative 0.2 pi, I don't want that as my C value. That's a mess. How do you even write that down without rounding? You can't. We want the equations to be in radians in terms of pi. So just don't put the pi in the calculator, but write it down where required. Certainly here we don't write it down because since this is division, the pi's cancel. Okay, but we're all set now. We have our C value. So now we've got A, B, and C determined. What does that mean? That means we simply take them and substitute them into this equation for y. So the equation becomes y equals, so first we write A, which is 3. Then we do sine of, and in the bracket should be B times X. B is 2.5, so now we have 2.5x. And then it's plus C, so plus 0.5 pi. Okay, and that's absolutely perfect. If you wanted to do this in fractions instead, of course you can, because 2.5 is the same as 5 halves, and 0.5 is the same as 1 half. So it would be perfectly fine to write the equation as, so should we just say or, if you are fraction crazy, fraction happy, you can do this. 5 halves x plus 1 half pi, or even pi over 2. Okay? So this, or even some strange combination would be acceptable. All right. So I hope that you understood those 2 examples. You will find 2 additional waveforms within the same document. You see these are numbered 3 and 4. One is asking you to come up with the equation of a sine wave. Okay, so that means you want to identify first, third, and fifth points on the axis. Okay, so you might want to start here, right? First point right there. So I won't give away too much for you. I'll let you handle it. But when you see sine wave, you want a first point to be a 0. So I would say maybe you want to start here and then identify or circle your other critical points. And in the next one, you are going to write the equation of a cosine wave. So circle 2 zeros, and those will be the second and fourth points of the graph. Okay? Okay, so I would say here, second point, here, fourth point. So then your job is to figure out what is the first, third, and fifth. Okay, give those a try. I've got the final answers here at the bottom of the handout for you. All right, thank you. Have a good day.